Welcome, everyone. I'm excited to kick off our session with Module 5, Memory Mastery Foundations. Today, we'll explore how to transform abstract numerical data into memorable experiences by using powerful techniques like chunking, peg systems, and coding methods. We'll dive into different number and data memory systems that can help you improve your recall dramatically. So, get ready to unlock the secrets of memory enhancement and take your skills to the next level. Let's get started. Today, I want to focus on how we can transform information overload into a real advantage by creating a clear and structured memory system. When we talk about structured mastery, we're emphasizing the importance of organizing complex information so that it's easier to access quickly. This means being able to retrieve detailed numerical data or statistics at high speed, which is crucial in many high-stakes situations. Then, we move to rapid recall. This is about leveraging effective systems that help turn abstract data, things that might seem just numbers or figures, into vivid, memorable mental experiences. When data is made memorable, it becomes much easier to recall when needed, giving you a distinct advantage over those who struggle to remember such details. And that brings us to the introduction of number memory, which is a key tool in this process. By mastering number memory, you're essentially equipping yourself with a powerful cognitive tool that makes complex numerical information more manageable, memorable, and accessible. This approach ties directly into the overall theme of optimizing how we handle information, turning data into a true memory advantage. Recall is often unreliable and slow, which can be frustrating when we're trying to remember information quickly. One of the main issues is that there's no emotional or spatial link to help us anchor memories, making them harder to retrieve. Without context, memories tend to be vague and fleeting, especially when dealing with long sequences of information. Our brains are also limited in what they can hold at one time, typically around 7 items, give or take 2, so short-term memory has its limits. This makes it hard to form clear mental images, especially for abstract data like numbers, which naturally lack visual meaning. Because numbers don't have inherent visual cues, they're particularly tricky to remember. This abstract nature creates a significant impact on our ability to retain and manipulate numerical information. This challenge stems from what we call a memory barrier, our mental constraints that hinder efficient memory storage and retrieval. Specifically, the difficulty of memorizing numbers highlights the broader challenge of numerical memory. Understanding these limitations helps us see why improving how we encode and connect information is so crucial. It's a key part of overcoming the barriers that make memory such a complex process. Let's talk about how we can improve recall efficiency. One effective way is to bypass the limits of our short-term memory. Our brains can only hold so much information at once, so finding ways to go beyond that is key. That's where grouping information into meaningful units comes into play. By organizing data into chunks, we make it easier for our minds to process and remember. This strategy, called chunking, involves breaking down large amounts of data into smaller, manageable pieces. Think of it as taking a long string of numbers and dividing it into groups, like phone numbers or dates, which makes them much easier to recall. Essentially, chunking helps us turn complex information into simpler, memorable units. By mastering this technique, we can boost our ability to remember more efficiently, which ties back to our overall goal of enhancing learning and retention. So, the next time you're trying to memorize something, remember, breaking it down into chunks is a powerful tool. So, one of the key ideas here is that the brain can remember about 7 words just as easily as it remembers 7 letters, but only if these are chunked correctly. When we talk about meaningful units, we're referring to organizing data into chunks that make sense. This process of chunking allows us to store more information within the same memory slots. Think of it like this. Instead of remembering a string of individual letters or numbers, you group them into larger, meaningful units. This expansion of capacity is why we can remember more complex information than it might seem at first glance. According to Miller's law, our working memory has a capacity of around 7 chunks, give or take 2. When we organize information into these chunks, we're effectively expanding what we can hold in our short-term memory. So, understanding how to chunk information effectively is crucial for improving our memory and learning skills. It's a core concept that ties into the overall theme of optimizing memory capacity. Now, let's talk about applying chunking techniques to real-world scenarios like credit cards, IDs, and phone numbers. The key here is to visualize each chunk as a vivid, distinct mental scene. For example, imagine seeing your credit card number as separate scenes in a movie, each one clear and memorable. It's important to ensure that these chunks are meaningful and not just random splits. We want each part to make sense, like a date such as 1985 or a time like 1430, which are familiar patterns we naturally recognize. Using these familiar patterns helps our brains remember complex information more easily. Remember, the goal is to create logical, memorable units that make recalling information smoother. This approach isn't just about memorization, it's about making information more accessible and less overwhelming. So, when you're trying to remember a phone number or an ID, think about dividing it into chunks that are easy to visualize and connect to familiar patterns or scenes. Now, let's look at how we can turn abstract digits into something much more memorable. The key idea here is to create concrete, pre-memorized images that act as anchors for new data. This is where the concept of mental hooks comes into play. By associating numbers with vivid images, we make them easier to recall later. The most popular method for doing this is called the PEG system. Essentially, it involves linking numbers to specific, familiar images or pegs that we've already memorized. Once these pegs are in place, we can attach new information to them, making the entire process more efficient and reliable. This approach is especially effective because it transforms the daunting task of memorizing raw digits into a visual and mental exercise. The images serve as permanent anchors, so each new piece of data is anchored to something concrete we've already internalized. In the context of our overall theme, boosting memory and learning, using the PEG system is a powerful tool. It leverages our natural ability to remember pictures better than abstract numbers, turning the entire process into something more intuitive and lasting. All right, let's talk about creating your number pegs using visual anchors. Think of this as assigning concrete images to numbers from 1 to 10, and I've chosen images that pack a real emotional and visual punch. For example, picture a pencil for 1, a graceful swan for 2, a sturdy tree for 3, a welcoming door for 4, and a buzzing hive for 5. These images aren't just random. They serve as powerful mental anchors that help you remember and recall information more effectively. When you connect these vivid images to your key points, it makes the information stick better and feels more engaging. This technique ties directly into our overall theme of memory enhancement and making learning more memorable. So, by assigning these impactful images to your numbers, you're building a mental toolkit that boosts your recall and makes your presentations or study sessions much more dynamic. All right, now let's bring this to life. Imagine milk dramatically spraying out of the tip of a pencil lead. Visualize that for a moment. We want to add emotion and motion here, so think about making that spray lively and exaggerated, almost like a cartoon. Next, picture a giant pencil writing the word milk in big, bold letters. This exaggeration helps to really anchor the concept visually and makes it memorable. Now, I want you to create an interaction. Imagine yourself or someone else actively engaging with this scene, maybe pointing or gesturing toward the pencil or the word milk, making it feel dynamic and real. Moving on, the key is to visualize that milk is item number 1, or peg number 1, which is associated with the pencil. Linking this item, milk, to a specific number peg helps us organize and remember the information more effectively. Finally, remember to assign each item a peg systematically. For example, milk is peg number 1, and the action here is to visualize and exaggerate it, making it stand out. This step-by-step process of assigning and linking items using the PEG system is what makes memory techniques like this so powerful and effective for retaining information. Now, let's explore how we can expand our system to a 100 PEG setup. which is incredibly useful for memorizing longer sequences like phone numbers, pins, or even complex statistical datasets. This involves using a spatial matrix, specifically a 10 by 10 grid, which gives us 100 unique pegs. The idea is that by increasing the number of pegs, we vastly improve our capacity to encode and recall more detailed information. Think of the 10x10 peg grid as a powerful tool for organizing and linking larger chunks of data in a way that's both visual and memorable. This approach opens the door to advanced applications of the peg system, allowing us to handle increasingly complex memorization tasks with greater efficiency. So, by expanding to this 100 peg system, we're really pushing the boundaries of our memory capabilities, making it a practical and versatile method for a wide range of information. Let's take a closer look at the core concepts behind the major system. First, you'll notice that vowels are ignored in this system. That's because the focus is on the consonants, which carry most of the phonetic information needed for encoding numbers. Next, we see the idea of phonetic associations. This means that specific sounds or consonant patterns are linked to particular digits, making it easier to convert numbers into memorable words or images. We also convert digits to consonants, creating a bridge between numerical data and linguistic imagery. This process helps us remember complex numbers by turning them into familiar words or phrases. Finally, the major system itself is a sound coding technique. It's designed to encode numbers into words based on these phonetic associations, simplifying the process of memorization and recall. Overall, this method is a powerful tool within the broader theme of memory techniques, helping us leverage sound and language for better retention. All right, on this slide, we're looking at the major system's consonant mapping, which is a really useful tool for memorizing numbers. Each digit from 0 to 9 is associated with specific sounds or consonants. For example, the sounds P and B are both linked to the number 9. Similarly, the sound R corresponds to the number 4, and so on. You'll notice that some sounds are grouped together. For instance, F and V are both mapped to the number 8, while M is assigned to 3. Moving further, K, C, and G all share the number 7, which helps us form words by combining these sounds. It's important to see how these mappings allow us to turn numbers into words, making recall much easier. For example, if you want to remember the number 94, you could think of bar or car, since B and C are mapped to 9 and 4 respectively. This system essentially helps us encode numbers as memorable words, which is a core part of the overall memory technique we're exploring. Understanding these mappings is key to mastering the system and improving our memorization skills. Now let's dive into how vowels play a role in making words pronounceable. Essentially, vowels like a E, I, O, U act as fillers, helping us form words more smoothly. For example, if we take some consonants and ignore the vowels, we can combine them into recognizable words. Like P plus L plus F becomes puff. It's a simple way to see how consonants come together to form meaningful units. Next, we have the concept of a phonetic bridge. Think of the word tin. We can break it down into its parts. T plus N. This helps us understand how sounds connect and flow in speech. When I see tin, I can associate it with the number 12, which relates to the major system. Speaking of which, the major system word formation is a powerful tool. It's a method that helps us encode numbers into words by using consonant sounds, making memorization much easier. So, by understanding these basics, filling in vowels, combining consonants, and creating phonetic bridges, we can enhance our memory techniques significantly. This all ties back to our goal of improving recall and retention through clever encoding strategies. Now, let's explore the fascinating concept that each person has a unique action, like running, which can be used as a mental cue or memory trigger. These actions help us create vivid associations in our minds. Next, we see that letters can form a person, such as TN for Thomas Newton. This technique allows us to turn initials into memorable characters, making recall easier. Characters, in this context, are essentially these personified initials or images that we link to information we want to remember. Then, there's the idea of two-digit numbers being converted into letter pairs, ranging from 0 to 99. This is a powerful way to encode data efficiently. All of these elements come together in what's called the mapping process, where we assign specific meanings or images to numbers and letters. And the key method we're focusing on is the Dominic system, which is a well-known technique for creating these associations systematically. Finally, the core feature here is the Dominic system's letter coding, which helps us translate numbers into memorable characters or actions, making complex information much easier to recall. This system taps into our natural ability to remember stories and images, connecting everything back to the overall goal of improving our memory skills. Let's take a closer look at these encoding pairs, which are essential for understanding how we represent information. Here, we see three key individuals: Kevin Flynn, represented by 78, Mary Lark with 35, and Thomas Newton, assigned 12. These numbers serve as identifiers for encoding purposes. The concept of pairs is fundamental because it allows us to link individuals with specific actions or data points, creating a structured way to organize information. In our context, Dominic focuses on person-action pairs, meaning each pair connects a person to an action or a related data point. This approach is powerful because it helps us decode complex information by breaking it down into manageable, meaningful units. When we encode data this way, it becomes easier to analyze, retrieve, and understand relationships between different entities. Overall, these encoding pairs form the backbone of how we systematically capture and interpret information, which ties directly into our broader theme of efficient data management and analysis. Let's take a moment to consider the importance of linking images to their historical context for better recall. On this slide, we've encoded the phrase, kite fiddle, using the major system to help us remember the key event from 1984. By creating this mental link, we make it easier to recall the details later on. The year 1984 is significant because it marked a pivotal point in history, especially in terms of technological and political developments. Connecting this image to the actual event ensures that the information sticks with us more permanently. So, whenever you think of this period or see this image, the association will trigger the memory of that major event from 1984. This technique is a powerful tool in our overall approach to effective learning and retention. Let's take a look at this slide, which features some familiar symbols and their connection to encoding statistical data. First, we have the image of the sun, which can symbolize clarity or enlightenment, important goals when working with data. Next, the key represents unlocking information, emphasizing how encoding helps us access and interpret complex data sets. Then, there's the mathematical constant pi, 3.14, which is well known in mathematics and signifies precision, and the importance of accuracy in statistical calculations. When we talk about pi, specifically 3.14159, we're highlighting the value of precise encoding in statistical data analysis. The phrase, encoding statistical data, ties everything together, reminding us that encoding is fundamental in transforming raw data into meaningful insights. It's like translating information into a language that computers or analysts can understand efficiently. Overall, this slide underscores the importance of encoding in statistical analysis. It's the key to unlocking clarity, precision, and deeper understanding within our data. Let's take a moment to visualize this unusual scene. 3 ladders climbing a tiger, and on the tiger's nose, there's a tiny mouse. Now, why is this image so compelling? Well, it's a metaphor for complexity and risk. The tiger represents a powerful, potentially dangerous situation, and the ladders symbolize attempts to navigate or climb through it. The mouse on the nose, that's often a symbol of small, seemingly insignificant details that can still have a big impact. In the context of data security, this image reminds us that even seemingly minor details, like phone numbers or personal data, are critical. These details are like that mouse on the tiger's nose, small but important. When we handle such information, we need to be cautious and aware of the risks involved. The key takeaway here is that managing data isn't just about big threats. It's about paying attention to the small, often overlooked pieces that can cause major issues if mismanaged. Whether it's phone numbers or personal data, these are the details that can be exploited if we're not careful. So, as we continue, remember that safeguarding data requires a careful, strategic approach, much like carefully climbing those ladders, avoiding the tiger, and paying attention to the tiny mouse. It's all connected to the overall theme of understanding and mitigating risks in data management. Let's take a closer look at this slide. On the left, we see these two circles or bicycle tires, which represent different concepts. The first one, C2 or light squared, is visualized as a monkey, symbolizing agility and quickness, kind of like how light travels fast and can change direction swiftly. The second circle, M, stands for mass and is visualized as an eagle, emphasizing strength and the ability to soar through space. The third element, E for energy, connects everything. It's the power that drives motion and change. Now, these visuals aren't just random. They help us understand how these concepts are interconnected. The formula, E equals mc2, encodes this relationship mathematically, showing that energy and mass are interchangeable, connected through the square of light. It's like saying, with enough energy, mass can be created or destroyed, and vice versa. By visualizing these ideas as animals and circles, we're making a complex equation more intuitive. This ties back to our overall theme, understanding the fundamental principles that govern the universe. And remember, this formula is a cornerstone because it links the concepts of light, mass, and energy in a very elegant way. Now, let's talk about how we can connect disparate data points in a meaningful way. When faced with complex information, creating a visual story can really help us see the relationships more clearly. One effective method is to assign process steps to a simple, intuitive system, like numbering steps from 1 to 10. This sequential approach makes it easier to follow along and understand the flow. The peg system is a great example of this, using familiar pegs or hooks to remember sequences. For example, you might think of the periodic table and associate elements with different rooms in your house, turning abstract data into a tangible, memorable map. Ordered lists and memory palaces are also powerful tools. They help structure information logically, making it easier to recall and organize. An example of this could be creating a mental palace where each room contains a specific piece of information or step in a process. Ultimately, by applying these systematic approaches, whether through visual storytelling, ordered lists, or memory techniques, we can create a structured data organization that enhances understanding and recall. This is how we turn complex, scattered data into a coherent system that supports our learning and decision-making. All right, let's take a closer look at this slide. We see a series of words and numbers that seem to be connected in some way. First, we have rope, lizard jelly. These could be examples of items or concepts that we might associate with certain patterns or categories. Then, there's the number sequence, 456. Notice that these numbers are in the middle, perhaps acting as a bridge or a code linking the words on either side. Next, we have tiger, nose, mouse, which again are different words, but they might follow a similar pattern or serve as another set for comparison. Then, we see 123, which is a simple sequential number pattern. Moving on, 3 ladders appears here, probably illustrating a visual or conceptual idea of multiple steps or levels. Lastly, there's an exercise labeled 10-digit phone number, which is a practical application of the concepts we've been discussing. Throughout this slide, the key idea is understanding how different types of data, words, numbers, and sequences, can be organized or connected. These examples highlight the importance of recognizing patterns, whether in language, numbers, or visual structures. Remember, the overall theme is about how we can interpret and utilize various data formats to communicate or solve problems effectively. So, these examples are not just random. They serve to reinforce our ability to see connections and apply pattern recognition in different contexts. Now, here we see Thomas Smith signing the historic document, which is the Declaration of Independence. As he's signing, Kevin Smith is next to him, waving a flag to symbolize patriotism and unity. Interestingly, the initials 76 and K's are highlighted here, pointing to the year 1776 and Kevin Smith's initials. This is a reminder of the pivotal year when the United States declared its independence. And over here, we have the exercise for today, focusing on the year 1776. This moment is crucial because it marks the birth of a new nation, built on principles of liberty and self-governance. When Thomas is signing, he's making a formal commitment to those ideals, and Kevin waving the flag visually reinforces the patriotic spirit of that time. Understanding this scene helps us connect to the larger story of how the colonies took a stand against British rule and laid the foundation for the country we know today. So, as we reflect on 1776, remember it's not just a year. It's a symbol of independence, courage, and the beginning of a new chapter in history. So, to achieve confident and repeatable recall, it's all about transforming abstract data into stories that stick with us. When we turn facts into stories, it becomes much easier for our brains to remember and retrieve that information later. Building meaningful mental associations is key here. Linking new information to things we already know creates a web of connections that strengthen our memory. Remember, just 10 minutes a day dedicated to these practices can significantly boost your memory over time. Mastery doesn't happen overnight. It's about consistent practice. By making these techniques a daily habit, you'll develop a more robust memory that you can rely on confidently.